All right, moving forward from where we were before. So far, so good. I'm looking at yours and looking at this, and I've got that there's a C. I agree with you on the C. Atomic mass of 5, it has to be there. It has to be C there. I'm a little concerned about something else, but I won't talk about that because you'll never know. Q. There's only one electron in its outer shell, but it has 4 shells. So 4 shells, so 1, 2, 3, 4 shells. 1 electron's outer shell. I love it. Perfect spot, perfect placement. You've got it. Okay. Next on the list, E family is made up of E, Y, R, and the standing person. Yeah, I don't. Atomic mass of 5. That's got to be wrong. This thing right here is really something. Oh, atomic mass of 5. Hey, atomic mass, not atomic number. So that can't be 5, right? It has to be something less than 5. It has to be over here. We're going to talk about C in just a second. So let me go back and talk about C here. C. Okay, it has atomic mass of 5, but that does not mean it has 5 protons. It means it has 5 protons and neutrons, which is less than 5. And it reacts Ci. Well, we have I right here, don't we? We already had I right there. I needs 1 electron to be happy. So in order to make Ci, it'd have to be 1 donating, right? Because there's no C2. So it has to be 1 donating, 1 receiving. It has to be less than 5. So it has to be this, which would be donating 2, or this, which is donating 1. So this has to be where C is sitting. Tricky one. I fell for it too. I was like, wait, this isn't working. I was concerned. Oh, yeah. So let's talk about Q. You already got Q done. Good job. Let's talk about 10. This is something you forgot. Families. What's a family? It says an E family is made up of E, Y, R, and the guy that's standing there. Now, families are up, down, right? Families are up, down, right? So if Y is the second one, this must be a E, Y, R, and the guy that's standing there minding his own business. Okay, and increasing mass. All right, I agree with your this placement. That's good. That is the heaviest element. It has to be, right? And then I'm looking forward to P is a period of 5 and is 2 plus 2, so that's where it's got to be. So far we're good. We're really close to the finish line, aren't we? So then we got to get to these weird ones that are a little harder. D is in period 2, and so period 2, so it belongs here. It makes the DI squared. Now remember, I's want 1 electron to become like whatever this was. This is L. To become like L. It needs 1 electron to become like L. So because it needs 1 electron, D must donate 2 if this is the formula, right? So it has to be in this period. So which one donates 2? This one donates 2. All right. Now, next up on our list is the most like carbon. Well, if you look at the regular periodic table, carbon is 6. So this has to be where carbon sits. This is where carbon sits. Oh, wait, but it's not carbon. It's most like element carbon. And it's the same family as H, T, and this weird boxy thing. And so this is F. Right, it says like carbon, but it's not carbon, so let's put an F there. All right. Got it? So that is our periodic table of elements so far. I think you can do the rest of them from there. You're pretty close, right? We're only 5 off. You know what a family, remember what a family is. You know what it's doing when it says most like water. That would be H2O. So you should be looking for things like that. And then if you're looking for balancing things, you should have things that balance by donating 2, receiving 1. So it should be 2 of the thing that's receiving, that sort of thing. Okay? All right, I think this gets you to the finish line. Let's hope it does.